Okay, in this video I'm going to explain how we can find the enthalpy change of a reaction from enthalpy changes of combustion. So the enthalpy change of combustion is defined as the energy released. It is always released, it's an exothermic process every time, when 1 mole of a substance is oxidized in excess oxygen under standard conditions. So again, 298 Kelvin, 100 kilopascals. So in order to explain how we can use enthalpy changes of combustion, I'm going to use the reaction equation for the hydration of ethene. So C2H4 reacting with hydrogen to make C2H6. So the first thing we need to do is we need to find the enthalpy changes of combustion values for each of these three substances. So these equations must be balanced to give us 1 mole, to be burning 1 mole of each of these substances. So C2H4 can react with excess oxygen, which would in this case be 3 oxygen molecules, to make 2 carbon dioxide molecules and 2 water molecules. And the energy change associated with that will be minus 1,411 kilojoules per mole. Hydrogen will also burn in excess oxygen. Now, excess oxygen for 1 hydrogen molecule is half an oxygen molecule, and that is going to form a single water molecule with an energy change of minus 286 kilojoules per mole. And ethane, C2H6, will react with 3.5 oxygen molecules to form 2 carbon dioxide molecules and 3 water molecules with an energy change of minus 1,561 kilojoules per mole. So there we have the enthalpy of combustion values for each of the substances in our equation. And again, we have 2 different methods we can use to find the overall enthalpy change for this reaction. The first is to make an energy cycle. Now, the energy cycle here is going to have the combustion products as the third point in our cycle. Since here we have the ethene, here we have the hydrogen, and here we have the ethane, therefore our combustion products are going to have to make the third point on our energy cycle. So, carbon dioxide, we're going to require 2 of those, water, and we're actually going to have to require 3 of those because we're going to have 2 water molecules from the 2 hydrogens there and a third one from the water there. So we can have an arrow representing the enthalpy change of combustion of the ethene, which we can already assign the value of minus 1,411, the enthalpy change of combustion of ethene. We can have an arrow representing the enthalpy of combustion of the hydrogen, which is minus 286 kilojoules per mole. And we can have an arrow representing the enthalpy change of combustion of the ethane, so minus 1,561 kilojoules per mole. Now again, in order to find the overall enthalpy change of this reaction, we need to go from our reagents to our product. So these 2 arrows are pointing in the correct direction, however the third arrow is not. We're going to have to reverse that. So our enthalpy change will equal minus 1,411 plus minus 286, and then we will subtract negative 1,561 in order to make this arrow point the correct direction, which gives us an overall enthalpy change of reaction of minus 136 kilojoules per mole. The second method that we can use, as before, as these are all enthalpies of combustion, we require excess oxygen for each of these. We can add the excess oxygen onto each side of the reaction, but since the oxygen is going to be making more oxygen on the other side, it doesn't contribute to the overall enthalpy change here. So there's no problem with adding excess oxygen on each side of our reaction, since we must have the same amount on each side. So that's not a problem. So the second method that we can use is, again, we can have our original equation. So ethene plus hydrogen gives us ethane. And again, I can add the excess oxygen that we need on each side. And again, we can have these equations underneath lined up in order to go from our reagents to our products. So first I can go from C2H4 plus 3 oxygens to 2 CO2 to H2O. I can go from hydrogen plus half O2 to form another water, and then I can go the reverse of our ethane equation here. So starting with my 2 carbon dioxides and my 3 water molecules, I can form my C2H6. So the energy for the first reaction was minus 1,411. For my second reaction was minus 286. My third reaction is going in the opposite direction to the enthalpy change at combustion, so it will be plus 1,561. And again, I can add all of these values together and get the overall energy change of minus 136 kilojoules per mole for the overall reaction.